We are moving on to 8.3. Here's the unit circle. We found out that the sine of theta is found by simply looking at the y value in the unit circle. The reason that's the case, if I draw a right triangle at 45 degrees, sine is opposite over hypotenuse, but in the unit circle, the hypotenuse is 1, so y divided by 1 is just y, so it is the y value. Cosine of theta is the x value. So what is the sine of 150 degrees? We go to 150, we look at that triangle, so this is 150 degrees, we draw a triangle, and that gives me 1/2. Okay? What about the cosine of negative 2 pi over 3? So 2 pi over 3 would be this rotation. If we do that same thing negative, we'd land here. What is the y value at negative 2 pi over 3? Or sorry, the x value. Negative 1/2. Everybody understand that? Okay. What about the tangent of theta? Well, if I draw, let's say, the tangent of 60, tangent is opposite over adjacent, which in this case is going to be y divided by x. So the tangent is simply the y value, the y coordinate, divided by the x coordinate. Okay? So right here, the y coordinate is root 3 over 2. The x coordinate is 1/2. How do you divide two fractions? Flip the bottom one. So 2 over 1. This 2 cancels that 2, and I get the square root of 3. Okay? Some of them can be a little bit tricky. What about the tangent of pi? So we look at pi radians, and we do 0 divided by negative 1, which is 0. Okay? What about the tangent of negative pi over 2? So this one right here. What would the tangent be? Negative 1 divided by 0, which breaks the calculator. So the tangent of negative pi over 2, it could either be infinity or negative infinity. I know it's a little bit weird, but we're going to say not possible, doesn't exist. Okay, there is no number that satisfies that. All right, what about the tangent of 7 pi over 4? So the tangent of 7 pi over 4 would be negative root 2 over 2 divided by root 2 over 2, which is negative 1. Everybody get that? If you want to write that out, we get negative root 2 over 2 divided by root 2 over 2. Flip the bottom. The 2's cancel, the root 2's cancel, and we're left with negative 1. Okay, now the hardest tangent, and it's really not that hard, is, we'll say, the tangent of 120. Nope, 150, sorry. The tangent of 150. That would be 1/2 divided by negative root 3 over 2. So 1/2 over negative root 3 over 2. Flip and times 2 over negative root 3. The 2's cancel, and I get negative 1 over root 3. But I can't leave it like that. So I need to multiply this by root 3 over root 3, and I get negative root 3 over 3. Okay. There are 3 other trig ratios. The one that matches up with sine is called the cosecant. And the cosecant is abbreviated CSC, and it is simply the y value flipped upside down. The next one is called the secant, and it is abbreviated SEC, and it is simply the reciprocal of the x value. And then the last one is the cotangent, which is the x value divided by the y value. So we have cosecant, secant, and cotangent, and they are just reciprocals of the sine, the cosine, and the tangent, respectively. What is the cosecant of 30? So we go to 30 degrees, we look at the y value, we flip the y value upside down, and we get 2. So the cosecant of 30 is 2. All right? What about the secant of 3 pi over 4? So we look at the x value at 3 pi over 4. Negative root 2 over 2 flipped upside down is going to be negative 2 over root 2. I have to fix that. So I do root 2 over root 2. And that gives me negative 2 root 2 over 2. And the 2's cancel. So the answer is just negative root 2. Okay. And what about the cotangent of 60? That's going to be the x value divided by the y value. So 1/2 times 2 over root 3. The 2's cancel, and I get 1 over root 3. So we do root 3 over root 3, and that is equal to root 3 over 3. Do you need to see any more of those? Think you got it? Okay. Let's take a look at your ALEKS assignment. In 8.3, there are a couple problems where you have to draw the angle. Where is 7 pi over 4? So we need to rotate, oops. We'll grab that and rotate it to 7 pi over 4. So positive goes counterclockwise, negative goes clockwise, and you can go all the way around if the angle is bigger than 360 degrees. So that takes care of the first one. So here you need the unit circle. 2 pi over 3 is in quadrant 2. What is the sine of 2 pi over 3? Root 3 over 2. Yep. Okay. So this says, what is the coordinate on the unit circle of pi over 4? So we go to pi over 4, the x is root 2 over 2, and the y is also root 2 over 2. Okay. The cotangent of 7 pi over 6. So on your unit circle, you go to 7 pi over 6, which is in quadrant 3, and the cotangent is going to be x divided by y. So you get negative root 3 over 2 divided by negative 1/2. The negatives cancel. You flip, and it's just the square root of 3. Okay. Reference angles. So in your unit circle, Your reference angle is always the angle created on the x-axis. So if I were to rotate to 150 degrees from here to here, this angle is called theta. The reference angle is the angle inside the triangle. So if I rotated to 150, what would the reference angle be? 30. And reference angles are always positive. So regardless of the rotation that you perform, reference angles are positive. Okay, what if I did negative 300 and 315 degrees? What would the reference angle be? Right, so we're going to rotate this way to here. This angle is theta. The reference angle would be 45. Okay, let's do the same thing in radians. What if my reference angle was 7 pi, or sorry, my theta was 7 pi over 6? So this is theta. What is this angle here? 30 degrees, but what would it be in radians? How far past pi did I travel? Pi over 6. 1/6. Right? So we did all the way to here would be 6 over 6. To go a little bit further is 7 over 6. So from here to here is 1 pi over 6, or just pi sixths. Okay, what about negative 7 pi over 3? What quadrant does that land in? No. Nope. Where is negative 7 pi over 3? So we're going to go backwards. How far to there? That's negative 3 over 3, right? So this is negative 3 pi over 3. How far to there? 6 pi over 3. So negative 6 pi over 3. So right here is theta. How big is this angle? 1/3 pi. I went all the way around, or sorry, back the other way. So all the way around, and an additional 1/3. So the reference angle would be pi over 3. So reference angles are always 90 degrees or smaller, and they're always positive. Okay. Same problem there. And okay. That is as far as we're going today. We'll finish 8.3 next time.